Okay, hi everyone, it's Carolyn. My question was, suppose that 13% of all fatal accidents involve teenage drivers, but only 7% of drivers are actually teenagers. So how does this statistic show statistical independence, or kind of prove it? So I started out, I did 100 for each for easy math. So out of every 100 drivers, 7 are teenagers. And out of every 100 fatal accidents, 13 involve teenage drivers. Excuse me. So then I made this contingency table. So 13 out of 100 represents the 13% that are teenagers involved in fatal accidents. So that leaves 87 for all other accidents that are fatal. And then teenage drivers, that's the 7%. So 7 out of 100. So yeah, that leaves 93 for the rest. And then I totaled up the columns. And yeah, like I said, I just did 100 for easy math, so that brings the total up to 200. Okay, so on page 346 in the book, I found this formula right here, the formula for independence, which states the probability of B occurring given that A occurs should equal the probability of B. So over here, I did A is the teen driver, which is 7 out of the 100, coming up here. The teen drivers, that's 7 out of 100. Then B, I did fatal teenage accidents, that's 13 out of 100 right there. Coming up here, teenage fatal accidents, total is 100. Alright, so please excuse all my scribbles. So you want to do the probability of the teen drivers and the probability of the teen accidents, A and B, going back to that right there. And you want to multiply those together, because as stated on page 347 in the orange box, it doesn't use these exact letters, but I'm using them just for, my thing. The probability of B occurring given that A occurs equals the probability of A and B, which that means multiply right there, and then divided by the probability of A. So A was the teen drivers, 7 out of 100. B was the teenage accidents, 13 out of 100. So then what I did there, come over here, multiply A and B. So 7 over 100 times 13 over 100 gives you 91 over 10,000. Excuse me. And that's over A, which is the 7 out of 100 from up here, the teen drivers. So then you do that math and you get those decimals right there, 0.0091 over 0.07, which gives you 0.013 for the probability of B given that A occurs. Alright, so coming back to the original formula, we know that this is 0.13 right here, so then we have to make sure that it equals the probability of B, which B was the fatal teen accidents. That's 13 out of 100, or 0.13. So they are equal, which means that they are independent of each other. See, if they weren't equal, then one would depend on the other, and yeah. Well, in this case, it doesn't. The numbers work out. So yeah, that's how they're independent of each other. Okay, thank you.